Wait a minute. Searching for the face mark. Finally. Wait a minute till I make adjustments. It won't take much time, just little time only. Okay, now everything okay, I think. Just check the board. Hope everything is visible. Or I have to come slightly down. Slightly down I will come, so that you can see the full board. Yes. Okay, up to there. Up to here there is no problem. Voice fully clear? If voice fully clear, we start. Remember, the powerful method, Kani's method, all the basic will be covered today. Voice fully clear? Actually, my voice has gone down because of cold. Little coldness. That's okay. You can just let me know first. Is the voice clear? Voice display. Both are okay? Don't delay. If you comment, both are okay, means I will start. Still no reply. Voice and display, both are okay. How much have to wait for reply? Both okay, thank you. Okay, I'll start. See, Kani's rotation contribution method. That basic derivation is done in your indeterminate structures course. That is in class number 5, I think yesterday taken. That is not for general public, it is a course. Today's class is class number 6 for those who are in the group. And of course, today's class is for public, because very important concept, how to analyze by Kani's method. Once the first question is clear, this will cover 90% of the requirement for Kani's method. See, both ends are fixed here. When the fixed end becomes simple support, or if overhang is there, or settlement given, that all will come in the course, not here. That will come in subsequent classes. See, we are doing SD method, MD method, Kani's method simultaneously there. Therefore, here today's class is meant how to analyze a 3-span continuous beam. See, ends are today fixed. Instead of fixed, if they are simple support, or overhangs are there, some corrections are there. The correction I will tell you later. In the group class I will tell you. Those who are general public, they should learn. Everything I can't upload in YouTube. Okay, now, this is a question. Analyze by Kani's method and draw SFD BMD. Just make a note. Note, this question already we solved by slope deflection method, moment distribution method. by seeing my class in the Zoom, I noted down the answer. See, noted down the answer which we got by SD and MD method. Correct answer? Tell me. Answer correct? This is the answer I noted down by seeing the video. I went to Zoom recording and saw the answer. Is this answer correct? Result we got by SD method and MD method. Is this result I wrote correct? Just check it fast. Tell me. Little fast you have to comment. The moment the lag is there. The moment you hear, comment immediately. Is this result we got? See, this is the last step today. Is it correct? MAB, MBA, unit annotated. Kilonewton meter clockwise positive as usual. Tell me, this result we got by SD and MD method, is it correct? You are taking lot of time for commenting. If you do this way, difficult take the class. First tell me, correct or not? Yes, correct. Okay. Therefore, today we are bound to get same answer. Remember, I told if answer is not tallying, I will not continue my teaching. Okay, leave it now. I hope that result will come. See, first, before I start the problem, I will explain. See, last time I derived. Then I wrote sigma m, etc. This one, sigma m dash 1o, r, k, etc. I wrote. During derivation, confusion comes. I told I am giving summary. So, before you start the problem, first summary, remember, this is permanently for Kani's method, for beams without support settlement or with given support settlement, and also for frames without sway. If sway is there, then new term is going to come. That you will be knowing in the course later when I go to what? Multi-story building. Okay, start. First of all, remember, result for a member XY. In general, you call a member XY. When you call a member XY, see, your X is called near end. Near end. Y is called far end. So, if I call AB, A is near end, B is far end. Suppose I want for BA, this one, you have to write BA. When you call BA, B will become near end, A will become far end. So, in general, for a member XY, the final moment means everything is over. The final answer, that is, see, this result we got by SDMD method. The final moment, MXY, all equal to M bar XY plus 2M dash XY plus M dash YX. Or M bar XY means fixed end moment, corresponding fixed end moment. 2 times of, see, remember, in our class, M bar means, remember, fixed end moment. M dash means rotation contribution. Be very careful. Once you understand everything, today slowly I will do it. Rotation contribution. So, 2 times of M dash XY plus M dash YX. Or, if you want to write by words, final moment equal to corresponding fixed end moment plus 2 times of rotation contribution at the near end, where you want moment. If I want for AB, 2 times at A. If I want for BA, 2 times at B. Or if I want for XY, 2 times at X plus rotation contribution at the far end. So, if I want for a member AB, MAB equal to M bar AB plus 2 times of contribution here plus rotation contribution there. If I want MBA, corresponding FPM plus 2 times of contribution at B plus contribution at A. Suppose BC is there. M bar BC plus 2 times of contribution at B plus contribution at C. In the class, if I tell contribution, it is rotation contribution, the name for Carney's method. The method is called Carney's rotation contribution method. Is this statement fully clear? Is this statement, tell me, fully clear? Now I won't explain once again. The final expression for moment, is the statement fully clear? We will apply later. I will apply very slowly. Past, tell me. Is it fully clear? We are not answering past. Fatapat answer, clear. In my class, usually clear only comes. Not clear, no one will ask. Only those who are irregular, those who does not know anything, they may tell not clear. I won't listen to them. See, again, this much delay means what? See, you are unnecessarily delaying. Tell, is this concept fully clear? Expression for, I am removing this one now. What is the expression for final moment? How much time shall I wait for a reply? One comment, clear or yes. Then sometime it will become irritating for not getting the answer. Even after telling so much you are not responding means what I can do? Shall I stop the class? That's all. For clear. See, this much time. Comment fast. Okay. Now I am going to remove this one. Why? I want more space. So final moment expression is clear. Now you will meet this one at the end of the class. When we calculate what? Now, one more note you make. Suppose the end is absolutely fixed. Remember, this rotation contribution, see, this rotation contribution, that is m dash, is a function of slope theta, there, theta. If it is absolutely fixed end, you know theta equal to 0. Therefore, remember, lastly note, rotation contribution at fixed support, that is m dash, is always 0. So, no rotation contribution, that is moment due to rotation. There is no rotation, equal to 0. So, remember, this m dash value for our question at A and D will be 0. If it becomes simple support, then it will be there. But actually what you can do is, you can reduce the work by replacing that simple support by imaginary fixed support, by taking modified fixed end moment and relative stiffness by changing. It will be taken as imaginary fixed end with 0 contribution. Therefore, what I am covering today is valid for any end condition. Correction I will tell you in the class, subsequent classes. Today you learn basic question. Okay, this much clear. Now remember, now problem is what? All of you know how to find fixed end moment. If anybody newcomer, sir, fixed end moment, how to calculate? Why you came to my class? That actually in the YouTube I uploaded for general public only. So fixed end moment I won't talk here. I will calculate but won't explain. It will be insulting for those who are hardworking. Now you know fixed end moment. Now you should know how to calculate rotation contribution at a joint or rotation contribution for each member at each end. That is m dash. The formula is rotation contribution at a joint for any member, m dash. This is derived in yesterday's class, equal to rotation factor at that. See, if you want contribution, you require factor. This is contribution, m dash. This is factor, r. Rotation contribution equal to rotation factor into a bracket term. The bracket term is sum of FPMs of all members meeting at that joint plus sum of rotation contributions, that is m dash, at the far ends of all the members meeting at that joint. Suppose I want rotation contribution at B. It is sum of the FPMs here plus sum of the contributions at the far ends, at here and here. If I wanted C, it is sum of the FPMs here plus sum of the contribution at this far end and this far end. This I will explain in the problem. Now, lastly, rotation factor at any joint for a member, it is exactly same as distribution factor. Only change is extra minus half. Minus half times either you can use relative stiffness or absolute stiffness. If you use absolute, fixed end is 4EI by L, hinge is 3I by L. If you use relative, stiff end is I by L, hinge is 3/4 I by L. This all I told you in the earlier class. But today I will write a note for this one. It is relative stiffness of that member for which you want R divided by sum of relative stiffness of all members meeting at that joint. This all I will calculate in the problem now. Therefore, is this part also clear? If it is not clear, it will be clear when I do numerical. Don't worry. It will be clear when I take up numerical. You need not worry now. That is not fully clear. Yes, it cannot be fully clear unless you solve the numerical. Remember, always problem becomes full clear when numerical is over. Okay, now start our question. Now you start. Remember, this is the summary of the derivation. Clear? This is summary of the derivation I told. Shall I start problem now? Shall we start problem first? Shall we start problem now? Yeah, question 1. Analyze by Kani's method and draw SFDBMD. This is the question. Yes, start. See, write steps. First step, copy the question. That I don't have to tell. If you want to prepare something, first what to do? Switch on the stove or ignite the stove. Electric stove we switch on or gas stove means ignite it. Okay, over. Problem over. Immediately you make a personal note. Personal note. Don't tell anybody. Personal note. See, this I will tell you every class. Okay. This way person. Actually get right here only. A pure personal note. See, A, B, C, D. A is absolutely fixed. Absolutely fixed. D is also absolutely fixed. End support, if it is fixed, make a note fixed. Now, B and C are intermediate supports. Intermediate supports. I told you earlier, intermediate support is not simple support. It can develop moment. We proved it. Intermediate support is considered as fixed support. It is considered as fixed. Considered as fixed for stiffness calculation. Stiffness calculation. For stiffness calculation, intermediate support is considered as fixed. In moment distribution method, for stiffness and carryover. Here there is no carryover. Okay, start. Now, first step. First write a note. Calculation of rotation factors. Rotation factors. Symbol is R. It is same as distribution factor. Okay. Now, you find rotation factor at every joint having at least two members. One joint is B, other is C. You require at B and C. Before that, make a note. We know that relative stiffness small k equal to I by L when I told you 1000 times you define relative stiffness based on what? Far end condition. When far end is fixed. Far end is fixed. Okay. Now, therefore, at B, if you look this side, far end fixed. At C, if you look this side, far end is fixed. Next question number 2, D is simple support. The correction I will tell you in the course, not here, not in YouTube. In the course I will tell you. Why? This is only one class I am uploading. So that those who are in the batch, any day, they can refer this question. Okay, now. And also, make a note. Intermediate supports. Intermediate, see, therefore, that is your A and D. Here, today's question. Intermediate supports are considered as fixed. Fixed. They are not absolute fixed for stiffness calculation. Stiffness calculation. Over. Now, prepare a table. Prepare a table. Small table. Joint. See, systematically do it. Joint. Member. Member. Relative stiffness. Actually, if you solve later, this story all not required. I am telling story to understand everything. Relative stiffness. Stiffness. Then, that is, symbol is small k. See, relative stiffness, symbol is small k. Okay. Relative stiffness. Then, write sigma of small k. Lastly, rotation factor R. We already wrote R equal to minus half into k divided by sigma k. That's all. We need at joint B and joint C. First joint is B. Okay. After B is complete, next joint is C. Over. Joint is C. See here. At B, two members are meeting. Here. This is common, sigma. Again, deviate. Okay, start. See now correctly. Come to B. Come to B. From B, joint B is the starting point. This side, BA. This side, BC. One member is B to A. See, B should be starting point, A. Other is BC. Right. BA. Far end A is absolutely fixed. Therefore, formula is I by L. You write the reason if you want. You make a note. Far end A is absolutely fixed. Then BC. Far end C is intermediate support. For stiffness calculation, it is taken as fixed. Therefore, that also is I by L. That also equal to I by L. Write the reason. This is I by L because far end is absolutely fixed. This is I by L because far end is intermediate support considered as fixed. Equal to. I by L. 1.2i. E is common. 1.2i by 6. 1.2i by 6. Here, 2.4i by 8. 2.4i by 8. Fast, add these two. Fast. Don't waste time. Fast, add those two. Fast. 1.2 by 6 plus 2.4 by 8. How much? I want ABC format. I never want decimal. Answer. Add those two. You are adding 100. You are taking 1 hour to add. It will become I by 2. Okay. Correct, I by 2. I by 2 correct. Good. You are not responding. If you respond this way, how to take the class? I by 2, correct or not? You take calculator, add those two. 0.5 will come, I by 2. Now, what you do is, divide this value by this value. Answer. 1.2 by 6 by I will cancel. Divide by 1 by 2. Tell the answer. Tell in ABC format. 1.2 by 6 divided by 1 by 2. Tell me the answer. What you get? What you get? What you get? 1.2 by 6 by 1 by 2. Tell me what you get. You should show response. 2 by 5. See, you will get 2 by 5. Other will come 3 by 5. That is the answer for which method? That is, we are not taken minus of. You have done only k by sigma k. So if you don't take minus of, you get 2 by 5 and 3 by 5. That is the answer for which method? Tell me. That is the distribution factor for which method? That is the result for which method? If you remember. That is result for which method? Moment distribution method. Into minus of is there. So this will become it will become 1 by 5. This will become minus 3 by 10. Correct? That will become minus 1 by 5 because by, see, 1.2 by 6 divided by 1 by 2 into minus of. High school level calculation. Minus 1 by 5 minus 3 by 10. Correct answer? Kani's method, it will change. One extra minus of. Correct answer? This I don't have to explain because high school level mathematics. Answer correct? Fast. Yes, now, that's okay. But in my class, I always want same denominator. So what I am doing is, see, 5 and 10, I am extending it as, instead of 1 by 5, I am writing minus 2 by 10. No harm. So that both has got same denominator. That is my convenience. Okay. Now start. Same way, do at C. First I will do. CB, one member. Other member, CD. When I do for CB, far end B is intermediate, considered as fixed I by L. When I go for CD, far end D is absolutely fixed I by L. Equal to, this is 2.4 I by 8, this is 1.8 I by 10. Add these two. I will do it because you will take lot of time. 2.4 by 8 plus 1.8 by 10. It gives you 12 by 25. It gives you 12I by 25. Now, this value divided by this value into minus half will give you reciprocal into 2.4 by 8 into 0.5. 5 by 16 minus 5 by 16, this value divided by this value into minus half will give you minus 3 by 16. If you remember, in MD method, you got 5 by 8 and 3 by 8. Remember? In MD method, we got 5 by 8, 3 by 8. The 8 became 16. Tell me, correct or not? Correct? Okay, done. This will complete rotation factor. I may forget later. I will write somewhere here. If I ask you, you may not tell later. Minus 2 by 10, minus 3 by 10, minus 5 by, minus 3 by. Okay, sufficient. Denominator I can make out because why? 2 plus 3 is 5, 5 becomes 10. 5 plus 3 is 8, 8 becomes 16. I can make out that much. I am not that much weak in subject. Okay, now, same problem. Where I kept that sponge. See, same, here. Okay. Now, this will complete what? Calculation of rotation factor. I told you, I will do systematic approach. Okay, now, start. Next step is calculation of FPMs. First of all, I should not explain, but there are so many people may be watching outsider. For them, briefly. This is already over. Calculation of FPMs. My symbol is M bar. Some people write MF. Some people put FM. Whatever you want. My convention is clockwise positive. And all values are in kilonewton meter. Now, Just for information for newcomers, when you find fixed end moment, you never bother whether support is fixed or support is intermediate or support is what? Simple support. Wherever support is there, without seeing A, B, both ends supported, both are fixed. B, C, both ends are supported, fixed. C, D, both are supported, fixed. See, next class question 2 is like this. There, stiffness will change. But when you do FPM, nothing, fixed only. Okay, start. First, consider AB. First, I will do it. AB. Both AB, both are taken fixed. Someone will ask you, what is the support condition? You tell them, keep quiet, don't disturb me. I am finding fixed end moment. Don't interfere. Whatever is there, I am taking fixed. They will tell, it is not fixed. If it is not fixed, method will take care later. Correction will come. Okay. UDL, how much? 20 kilonewton per meter. This is A, this is B. See, this is anti-clockwise, clockwise. First of all, this I told you in the YouTube class earlier before my course started. It was for public. First of all, I should not explain. And see, this is UDL. WL square by 12. This also is WL square by 12. Some people, highly intelligent, they write minus here, plus here. They are creating blunder. Once you show it is anti-clockwise, you should not write minus. When you calculate with sign convention, there you use minus. When you write formula and show anti-clockwise, writing minus is the height of foolishness. So many top educators are doing it. Let them do. I am not that much top. I am average or very low level. Okay. Start. M bar AB. Now remember, our sign is clockwise positive. It is anti-clockwise. Minus W. 20 into span is 6 meter, 6 square by 12. Fast tell the answer. Fast tell the answer. Answer. M bar AB. M bar AB. Answer. Answer fast. Do not waste time. You tell the answer fast, I can continue. Because today we have to do lot of calculation. This question should be completed today. Minus 48.33. Abba. What is this? What? You are giving me final answer. You are giving me final answer. I am asking you to prepare an item. What item? Say for example, I want to prepare some item, palav. You tell how to prepare palav. Directly put the palav. If we are not eating the palav, we are preparing the palav. When you prepare the palav, put oil, then some extra things, masala items, rice, then what? You tilt it, something, etc. Prepare the palav. You are telling directly the answer. This is, do not see this one. This I wrote you, this I wrote for my commitment. You are seeing, if you get this answer, then why you want Kani's method? Okay. Minus 60. M bar BA is plus 60 over. Okay, then, okay, I'll remember now, minus 60 plus 60. Okay, later. Consider BC. I'll write here. Consider BC. You are creating wonders. When you consider BC, B and C both are taken fixed. Some people ask you, are they really fixed? You should shout back at them, hey, don't talk. I am finding FPM, don't interfere. When you find FPM, I am taking both fixed. See, it is central load, anti-clockwise, clockwise, central load formula, WL by 8, WL by 8. So, M bar BC is anti-clockwise minus W100 into 8 divided by 8 is minus 100. M bar CB is plus 100. BC also over. Okay. Don't write. No, lastly, CD member. Both C and D are taken as fixed. C and D. This time there is an eccentric load here of 40 kilonewton. From here to here is 3 meter. This is 7 meter. Span is 10 meter. Anti-clockwise here, clockwise here. If I call this as A, this is B. Formula is load into this distance A into other square B square by L square. This is load into this distance B into other square A square by L square. So this all I told you in the YouTube class only. So even those who are newcomers, I will tell them go back there. I uploaded class on YouTube for so many FPM. If you cannot read that one, then don't come to my class. Minus 40 into 3 into 7 square by 10 square. M bar DC, you have to calculate, plus 40 into, from there, 7 into 3 square by 10 square. Fast tell these two FPMs. Start. This is minus 58.8 last FPM plus 25.2. Correct? FPMs are correct? Minus 58.8. Don't tell wrong value. If you take one wrong value, your answer will not come. Others confirm. Suppose you give a wrong value, later answer will not come. I will stop the class today only. From tomorrow I won't continue. Because you are that much careless. Is the FPM correct? Confirm it. Oh, correct. Okay, over. FPMs are over. See now only remaining. Now I will do one thing. I will clean the full board now. I will tell you now. Now FPMs are over. Okay, write the answer here. It is minus 58.8 and 25.2. Okay. Now make a note here. Now only remaining is calculation of your M dash, the most powerful term of Carney's method, that is rotation contribution. Once you get that one, you can find the final moment. Clear? Now left out is only M dash, the most powerful in Carney's method. Once you get that one, you get the final moment. Clear? I will completely clean the board and what? Start fresh page. Full fresh I want. I want to show you specimen calculation. Clear? Okay. I will rub the board and complete board I will make clear now. Okay. Wait for little time. Full board to be cleared now. Except that answer. See, I do not want anything now. No problem required, nothing required. Every information I got each and every information which I want. Okay. I want a small break. I will take little later after I enter table for contribution. 1 minute. So that you can, when I take the break, what all I told, you can observe it. Or in the YouTube only, what you can do, you can go slightly backwards by 5 minutes and listen once again what I told just now. Agreed? When I write a table, I will explain something for you now. When I take a small 5 minutes break, what you do? You go back by around, you can do it. See, YouTube, Zoom, that facility is not there because you get the recording after the class. In YouTube, you got facility. So what you can do, when I take the break, you go back by around how much time? See, you see how much time? Now see the watch. Now it is 8:16, 17. You go back by that much time. When I come back, you go through once again. Agreed? Agree or not? Slightly go backwards. You can see the time also. Minus time will come. Okay. Now see. What you have to do is, see, our continuous beam is like this. This. A, B, C, D. Now heading is, see, calculation of the most powerful term, I write here, rotation contribution. Rotation contribution. I will tell you something now. That is called M dash. The number one of Kani's method. For that, you prepare a table. See, support A is here. Write support A here. Support A. Absolutely fixed. Go this way. This is your A. After A, go to B. B is a joint where two members are meeting. One member is BA, other is BC. There, you prepare a box. Prepare a box. Prepare a box. Little bigger. Very clearly I will explain today. Systematically, box. Once this question is over, everybody in future, you will have no difficulty for executing Kani's table. Then, go back here. Once again, a support, a joint, right here. Full board I am using. Okay, see, little more. So that no confusion. Okay, then, again go back here. This is fixed. Name the point. A, B, C. Where you found rotation factor, there you prepare a box. Fixed ends, you mark as it is. Now, first do one thing. You enter fixed end moment. Remember, FPMs enter. You write a note here. Above the line. Enter above the line. Enter above the line. I am telling some little crude method. Therefore, remember, values entered above the lines are what? Values entered above the lines are what? Tell me. Values entered above the lines are what? Tell me. Values FPM means M bar. FPM means M bar. Values entered above the lines are what? Tell me. What? Some confusion will come now. Some values are coming above the line, some are coming below. Make a note. That's what I told. When I take a break, go through my statement again and again. Values entered above the lines are what? Tell me. I won't repeat. Values which are entered above the lines are FPMs. Don't change your mind. ಸ್ವಲ್ಪ ಟಿಲ್ಟ್ ಆಗೋಯ್ತು, ನೋಡೋಕೆ ಅಸಹ್ಯಾಗಿದೆ, ಇರಿ ಸರಿಯಾಗಿರಲಿ ಪಾಪ ಯಾರನ್ನತ್ತೆ, ಇಟ್ ಲೈಕ್ ಟಿಲ್ಟೆಡ್. ಓಕೆ ನಾವು ಸಿ. ಸೊ ದೇರ್ ಫೋರ್ ಸಿ ಹಿಯರ್ M bar AB minus 60, M bar BA plus 60, M bar BC minus 100, M bar CB plus 100, M bar CD minus 58.8, M bar CD plus 25.2. These are the values entered above the line. These are the FPMs. Remember, these are FPMs. And below the line, write rotation contribution symbol already there. Next, M dash. M dash means rotation contribution. Enter below the line. Below the line. Therefore, the most powerful term, blue, that is the colored one. The colored one, M dash. So this is your M dash for AB. This is your M dash for BA. This is your M dash for BC. This is your M dash for CB. This is your M dash for CD. This is M dash for DC. Now do one thing. Wherever fixed end is there, tell me, I told you already. Wherever fixed end is there, tell me contribution. I won't tell again and again. Last time, wherever fixed end is there, I told you rotation there. How much? I won't repeat again and again. This is the last time I am telling. I got a limit for explaining. I am losing my voice because of coldness. 0. A is absolutely fixed without seeing here and there. 0 equal to 0. Clear? Therefore, now you need m dash BA to be calculated. You have to calculate m dash BC. You have to calculate m dash CB. You have to calculate m dash CD. Fully clear? This is your calculation. At A and D, no calculation. 0. Tell me, full clear? First, full clear. I will not explain. Tomorrow when I continue your course in Zoom, I will not explain this one. Remember, see, when I continue your course tomorrow in Zoom for next problem, I will not explain this one. Okay. Then, here what you do is, in the box, you prepare one more box inside. Like a foundation. Sometimes, sir, looks like foundation. And make it look like tapered foundation. Clear? This is the way I want to write. This is very popular. This way. Here, inside the box, write rotation factor. These are rotation factors. Rotation factors. They are not contribution. Contribution is a colored one. Our most important contribution is colored today. Colored, banna, rangila. This is R for BA. Here write R for BC. Here write R for CB. Here write R for CD. You already got the answer there. Equal to, see, minus 2 by 10 equal to, alide, minus 3 by 10. R for CB equal to minus 5 by 16. ಕಾಣ್ತಾ ಇದೆಯಲ್ಲ ಕಣ್ಣಿಗೆ minus 5 by 16 equal to minus 3 by 16. This is also clear. Inside the box, sides, central value pending. This is the last one. Wait for some time. Some entry is coming here. I will tell you later. This is still pending. The enters this way are factors. Factor means this is used to calculate contribution. Clear? Factor is used to calculate contribution. Clear or not? Factors are used to calculate contribution. Clear? First. I will tell you how to calculate. Tell me clear or not. Okay, clear. Okay, now, here you write sigma of m bar. Here also write sigma m bar. That is some, see, later this is the FPM, this is the FPM. We do not want individual FPM for the table. When you do final moment you require. When you do the table here, you do not want individual FPM. We want combined FPM. So 60 minus 100. Tell the answer, don't change the sign. In MD method, here don't change the sign. Sum of the FPMs here. Answer. Sum of the FPMs there. Eto, how much? Sum of the FPMs there. Little fast. Sum of the FPMs there. Minus 40. Minus 40. Same way here. Sum of the FPMs here. Answer. Sum of the FPMs here. Minus 40. ಅಯ್ಯಯ್ಯೋ ಹಳೇದು ಆಗೋಯ್ತು. Other joint. Sum of FPMs there. Other joint. Plus 100 minus 58.8. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? plus 100 and plus 41.2. I plus 41.2. See, in the first question, it came negative here, it came positive here. In the second question, tomorrow or day after tomorrow, not in YouTube, in the Zoom class, I have taken care, this will come positive, that will come negative. One more class, both will come positive. Another class, both will come negative. That you take care later. Now that is not important. Now we want this value, this value, this value, this value you want. Now see, suppose you are writing examination, now you have to enter the value. But what happens is, people will expect you, they will tell, show the calculation. So what I will do is, I will show here specimen calculation. Specimen calculation. Calculation. Specimen means more and more cycles are there. You need not show calculation for all cycles. For 2 cycles, calculation of rotation contribution. Rotation contribution. That is M dash, our banna. M dash. Remember, for 2 cycles, see, only 2 cycles sufficient in the class. Then you can do sufficient. Oh, start. Now I will show specimen calculation. Start. I will see first cycle. I will tell you why cycle. I want calculation at B and also calculation at C. Then I want seconds, B and C. Jaga idya? Iriri. Oh, space is there. Then next I want second cycle. Second cycle. Again I want calculation at B and calculation at C. One nimsha. I will explain fully, don't worry. Everything will be explained. I should check whether paper is okay or not. Paper means space is okay or not. So that you should not tell not visible. Both are visible. Tell me what I wrote on the board. Fully visible. What I wrote on the board fully visible means I am ready for calculation now. What all I wrote on the board fully visible. Past. What all I wrote on the board fully visible. Yes. Now I talk non-stop for 1 hour. I'll take 5 minutes break. Nodi. I told earlier time 7:21 like that. You go back by previous 6 or 7 minutes and go through what all I told. Agreed now? When I take the break, what you do is, see, what you have to do. Suppose you are here. Come to this side. I'll tell you what you have to do. If you are really serious, see, slightly this side. Okay. Then, volume. I can hear. Yes. See, you can hear now. I am switching off. That way, don't waste time. What all I told about the table, go through and get ready for the starting of the last part. Okay, I'll remove it. Okay, I'll remove it. Remove the voice. I showed you. Those who are serious. It is not going? Okay. See, that's how people should be serious. Agreed? Agreed or not? Don't waste the break. When I take the break, you use it for going through what I told just now. Agreed? If you are serious, you have to agree. Because later, doubt should not come. Okay. I will come in 5 minutes time. Okay, 5 minutes time. I use color for the contribution, the most important term. Voice clear? Can I start? Voice clear? Can I start? What all I tell, go through, correctly understand. After the class is over, repeatedly go through and practice and get the answer. Clear? Because this will not come again and again. From tomorrow when I change the question, this table I am not explaining. It is standard for at least 10 more questions. The table remains same. The further procedure is same for 10 more questions. Next time what I will do, I will enter here, see, I will tell you next time what I will do. I will write here zigzag answer. Zigzag answer. That is, you struggle and get it. No one should tell me, sir, how to get it. So that is, repeatedly go through. Okay, now come to the most powerful part. See, start. We want rotation contribution at B and C. At B, I want M dash BA and also M dash BC. Then at C, I want M dash CB and M dash CD. See, here I want at B. When I do joint B, I want M dash BA, M dash BC. When I come to C, I want M dash CB, M dash CD. Okay. This is what you are calculating now. I will remove question mark. Okay. Start. The basic statement, I will tell once again. Rotation contribution at any joint for any member equal to respective rotation factor multiplied by a bracket term. The bracket term is sum of FPMs of all members meeting there plus sum of rotation contribution at the far ends of all members meeting there. So if I do at B, first I want sum of the FPM. See, this minus 60 plus 60 are FPMs. We do not want individual FPM. We want sum of FPM. It is here. How much? It is minus 40 here. Correct? First term is sum of FPM or crude method. Inside the box value, see, crude method, that inside the box value, clear, minus 40. Clear or not? Systematically, sum of the FPMs or crude method inside the box value plus rotation contributions at the far ends. Tell me, if by contribution means colored value, if I come this side, tell me contribution here first. At B, if I look that side, tell the contribution, tell the answer. Tell the contribution this side, far end. First, contribution this side, far end. When I do at B, that side far end contribution, not FPM. How much? Contribution. Rotation contribution. How much? First. To tell the answer there. 0. This is permanent 0. 0 plus that side contribution. This one. Do you know it? Tell me. See, this side far end is 0. That side far end. Do you know it now? Tell me. Do you know what is this contribution? Tell first. It is not 0. Do you know it? Do you know it? The contribution there. Do you know it at present? First. No. If it is not known, you tell you are temporary 0. Clear? Temporarily 0. Actually, without knowing that value, you cannot solve here. Same way, when you come to C, you want this value, not known. Therefore, without knowing far end, you cannot calculate at near end. helpless. See, when you go to B, you require this value. When you go to C, you require this value. So what to do is, initially, if something is not known, if it is not available, temporarily take it as 0. Clear? See, this is temporary 0. Clear or not? Temporary 0. Clear? It is not 0. Temporary 0. What to do when it is not known? You take temporary 0. Clear or not? See, I want this side far end contribution. Contribution means C below the line, colored value. This side really 0. That side not known. So time being 0. Tell me, clear or not? Clear. Okay. Now, this whatever you got, multiply by respective factor minus 2 by 10 this side, and same value multiply by same value here. This is common for the joint. Minus 3 by 10 that side. Remember, minus 2 by 10. If this value is negative, you will get a positive. If this value is positive, you will get negative. Second decimal, tell the answer. Second decimal, tell the answer. Second decimal, tell the answer. Into minus 2 by 10. Multiply by respective rotation factor. Answer. See the statement given. Respective rotation factor into sum of the FPMs plus sum of the contributions at the far end. Answer first. Plus. How much? Why plus? Because minus is there into minus. Answer first. Don't waste time. 2 cycle you should tell. Third cycle I will do it. Third cycle onwards I will do it. You agree with me? Plus 8. Other one. Same value into minus 3 by 10. Answer. Plus 12. Immediately go back and enter. Enter. Remember, it is a colored value. Sorry. Plus 8 plus 12. Enter. Equal to plus 8 plus 12. Okay, enter. Fully clear? I will tell once again procedure. Sum of the FPMs here or crude method inside the box value plus far ends contribution which are below. So inside the box value here and far end below values multiply by each factor will give contribution. Fully clear? Tell me. Full clear? More cycles are there. Tell me. Full clear? ಇಷ್ಟೊತ್ತು ಬೇಕಾ ಫುಲ್ ಕ್ಲಿಯರ್ ಅನ್ನೋಕ್ಕೆ? Full clear means next joint I will go. You are delaying a lot just to type clear. You tell clear because clear. Okay, now go to C. When you go to C, same procedure. Sum of the FPMs plus 41.2 plus this side far end. Oh, now you know the value there. What is that value? It is plus 12. Just now you got it. Plus that side far end is permanently 0. Or crude method. Inside the box value plus this side below the line. This side also below the line. Inside the box plus this side far end below the line. This side far end below the line. Okay. Now, what you do is, same thing, multiply by minus 5 by 16. Other one is minus 3 by 16. Answer first. Tell the first answer. Second decimal sufficient. Answer. From tomorrow in the class, Zoom class, I will not explain. Answer. See, I will put the table and walk out. I will come after 5 minutes. I will tell you get the answer. You should take your calculator and operate. Answer. This much time for answer. Minus 16.63. Other one. Second decimal answer. Other one. Minus 16.63. Other one. Other one. Little fast. Only one value you give. Do not give wrong value. But one advantage. If you make a mistake here, the method will correct it. Advantage is there. See, you should not make any mistake up to here. When you calculate contribution, if you make a mistake, the method, it is an auto correction. Method will correct. Number of cycle becomes more. Sorry, you gave one value and stopped. Other value you did not give me. What is this? Only one value you gave. How much time shall I wait? When you give that value, why don't you give second value also? Minus 9.98. Go back and enter. Right here. A zero beta. Equal to minus 11.63 here equal to minus 9.98. Is the first cycle fully clear? I will tell you now why it is called cycles. Is the first cycle fully clear? Past, tell me. Now I am going to tell you something. If the first cycle is fully clear, I am going to tell you something now. Past. If you tell full clear. Okay, now, see. Now people will tell, sir, work over. Work is not over because, see, when you started at B, this side far end you took 0. That side far end you are not knowing. You took it as 0. But now, that side far end changed. If this value is different, then these two values will also change. If that is, when that value changes, last time you took 0. When it is a new value is there, because of that value, these two value will change. When these two value changes, next time again these two value will change. When those two value changes, again these two value will change. So it will keep on changing. Finally, within the least count, value will repeat. Means what? The difference will become so small that the change taking place there will not create change there. Therefore, you have to continue procedure till everywhere values are repeated. Clear? Everywhere values are repeated. Repeated means what? No change. Okay. No. If this is wrong, nothing to worry. Nothing to worry. I can put 1 crore here also. If I write 1 crore also, it will give. Okay. Minus 16.63. Okay. Print mistake. Now clear what I told? Therefore, second round, third round, fourth round will be there. Now clear what I told? No. What I told is clear. That change will change here. This change will change there. Is the sequence clear? Any far end changes, this will see. Change at C will change the value at B. Change of B will change at C. Is it clear? This step. Fast. You tell me clear. Okay, now go to second cycle. Second cycle. Once again come to B. What do you want? We want M dash BA and M dash BC. Start. Come back once again to B. Sum of the FPMs minus 40 or crude method inside the box value plus far end value there is absolutely 0 plus far end this side. Oh, new value is there. It is minus 16.63. Last time when you do at B, you took it as 0. Now there is a value there. So that value repeat multiplied by this side minus 2 by 10 multiply that side by minus 3 by 10. Tell fast values. Tell me both the values fast. Tell me both the values. Revised value. Tell me both the revised value. Over. Just 5 minutes more. Contributions are over. Problem will be over. Today's class will not go up 9:30. You can be free at 9:15. 9:15 class will get over. Answer. You should give fast answer. Revised value at B. Tell me revised value at B. B. Second round value. You tell fast, I can also do fast. Plus 11.33. Other one. 11.33. Other one. Fast. Other one. You give one value and keep quiet. Why? Why only one value you are giving? Give both the values. 16.99. Oh, there is a mistake. It is not 2 by... yes, plus 16.99. Now remember, right? Go back and enter. But remember, this entry is not like MD entry. It's a correction. Go back, comma, cut or cancel. Cut or cancel previous value and enter new value. Clear? In Kani's method, when you once again come back, previous value is cancelled. Or, see, cut, not add. Cut, and enter new value. Plus 11.33, cut, enter, plus 16.99. Clear? Cancel the previous value, put the fresh value. Now previous value gone. It is revised value. Tell me, clear or not? If clear, I won't ask you much now. If clear, I won't ask you much now. If you tell clear, further I won't ask much questions. Fast. Clear. Okay. Now, come to C once again. Start. We want M dash CB and M dash CD. Tell the answer. Sum of the FPMs or crude method inside box value plus 41.2 plus rotation contribution at the far end. Last time you took 12 instead of 12, now it is plus 16.99 new value. This side far end is 0. Over. Repeat. Multiply by here minus 5 by 16, here minus 3 by 16. I am asking you last value. That's all. Next I will do it. Next I will do. You don't have to. This is the last answer you have to give for the table. Then you have to give only final moments. Answer first. Tell the answer. Type both the values. Instead of last time 12, see, after the class, you have to go through the class again and again and practice and get full grip. Minus 18.18 and also minus another value. One more value. Fast. One more value to give over. I won't ask you anything now. Minus 10.91. Right here. Go back. Right here. Go back and cut the previous value. Enter fresh value. Minus 18.18 minus 10.91. Is the two cycle fully clear? Tell me. Is the two cycles fully clear? Because now you need not show calculation. Only take calculator and do it. See, now right. Further rounds, you take calculator, do it and repeat. Okay. Now, I will remove the specimen calculation. I do not want this one now because fully clear. Okay, 1 minute now. We are coming to end of the class now. See Kani's method, how fast it is. This is specimen calculation. We don't require now. Okay, now see. What I am doing is, see correctly, what I am doing, you never take your calculator now, unless you got capacity. See, I will do it by telling you, but you write after the class. Okay, start. Now, I will take my calculator. Once again, come to B. See what I am doing. See correctly what I am doing. Minus 40, far end 0, far end this side, minus 18.18. Whatever I got, I multiply by minus 2 by 10 into 2 divided by 10 minus. Cut the previous, it becomes minus plus 11.64 second decimal. That side plus 17.45. Clear? Tell me. You can do it later, not now. After the class you try. You correctly see what I am doing. Clear now? Tell me. Third round. Clear? Okay. Now, come to C. 41.2 plus far end there plus 17.45 plus far end here is 0 into minus 5 by 16 cut plus 18.33 plus 10.996 is 11.00. Okay, again come back to B. Minus 40, you can see values are converging. Minus 40 plus this side is 0, that side is plus 18.33 divided by 10 into 2. Into 2 by 10 is, oh, something wrong. I can make out. Minus 40, I can make out. Into 2 by 10. Minus 4 point. How it is possible? Oh, it is negative. Oh, okay. See, I can make out something wrong. Negative it is. Okay. Minus 40, because I can make out, is plus 11.67. That side. Plus 17.50. Go there. 29 point. ಎಲ್ಲಿದೆ 29 ಪಾಯಿಂಟ್ ಇದೆ ಅಲ್ಲಿ 29 ಆದರೆ ಎಷ್ಟದು ಅರ್ಥವಾಯ್ತು ಬಿಡಿ ಪರವಾಗಿಲ್ಲ. ಹಿಯರ್ 41.2 plus 17.5, that side is 0 into 5 by 16 is minus 18.34. It is minus 11.01. Minute change. Once again come back here. Minus 40 plus 0 plus minus 18.34. See, small change. When I write second decimal, answer is minus plus. You can calculate some problem. Minus 40 minus 18.34 plus 0 2 by 10 minus 11 plus 11.67 plus 17 actually 502 came second decimal 50. Therefore you can see both the values at B repeated. Now, I will come to C here. See what I am doing. Minus 18.34 cut minus 11.01. Tell me, everywhere values got repeated. Everywhere values got repeated. Tell me. Everywhere values got repeated. Past. Everywhere values got repeated. Past. Everywhere values got repeated or not? You are not answering. Yes. Therefore, table over. Now, last step. Remember, last step. Calculation of final moments. Final moments. All values are, now, all are clockwise positive, or I will put last term. Final moment. Remember, just to understand, I will write the statement here. See, statement. mxy equal to m bar xy plus 2 times of banna what? M dash xy plus m dash yx. Just to understand, this is fixed end moment. This is, see, rotation contribution. Space is not there. Rotation contribution at near end. This is rotation contribution at far end. Fully clear? mxy equal to m bar xy plus 2m dash xy plus m dash yx. Tell me, full clear? Okay, now start. How to calculate? Start here. I want first, see, this moment. MAB. See correctly what I am doing. MAB. Now you require individual FPM. M bar AB minus 60 plus 2. I am doing MAB. When I do MAB, my finger is A. 2 times of contribution there. 0 plus rotation contribution at the far end. Far end is plus 11.67. Tell me, MAC, when I want MAB, FPM 2 times contribution here plus far end or crude method. Final moment is upper value plus 2 times of lower value plus lower value at the far end. Crude method. Answer. MAB minus 46. Oh, I will stop my class forever. My SDMD answer is minus 48.33. If you tell 46.33, from tomorrow I will not continue education. Yaru 46.33 ನನ್ನ ಕ್ಲಾಸ್ ಅಲ್ಲ, ಇನ್ ಮೈ ಕ್ಲಾಸ್. ಮೈನಸ್ 48.33 ಕಿಲೋ ನ್ಯೂಟನ್ ಮೀಟರ್. ಓಕೆ, ನೌ MBA equal to, see, now I am doing, see now, this moment, MBA, this moment, corresponding FPM plus 60 plus 2 times of contribution at B for BA plus 11.67 plus far end contribution is 0. Tell the answer. MBA first. Tell MBA first. MBA. What is the answer you are getting today by Kani's method? MBA. Your MDSD answer is still waiting there. Minus answer plus 83.34 plus 83.34 kilonewton meter. Okay, now Tell me your answer by SDMD method. Tell the answer. SDMD method. What is the answer? Tell me, what is the answer by SDMD method? SDMD method. Answer. SD and MD method answer. It is there. Same. 83.34. Okay. Same answer. Same. Okay. Then MBC. Now this is for AB member. Okay. Now go for BC member. What do you want? MBC and MCB. See now. This over. Now for BC member. First, this moment. Corresponding FPM minus 100 plus 2 times of rotation contribution there plus 17.50 plus far end contribution minus 18.34. Tell the answer. Answer. First answer. FPM, see this moment. FPM minus 100, 2 times this contribution plus far end contribution. In my class, contribution means till I come to sway problem, it is called rotation contribution because there we got 2 contributions. One of them is rotation, other is displacement. So till I reach sway problem, if I tell contribution means rotation contribution. Minus 83.34. So beautifully tallying. See here. So beautifully tallying. Now MCB this moment. FPM plus 100. 2 times of contribution there minus 18.34 plus far end contribution plus 17.50. Tell the answer. MCB fast. MCB plus 80.81. 81. Then MCD. Okay, which one? BC member over. Lastly, this member. Consider CD member. MCD and also MDC. Start. MCD means this moment. FPM minus 58.8. 2 times of contribution for that member minus 11.01 plus far end is 0. Answer. You have to get minus 80.81. Are you getting? All are in kilonewton meter clockwise positive. I forgot to tell. Are you getting? Are you getting or not? Okay. Now last member, which one? MDC. Corresponding FPM plus 25.2 plus 2 times of contribution there is 0. 0 plus MDC contribution at the far end minus 11.01. Answer. Over. I won't ask you anything further. See, if it is an offline class, sometimes I explain this once again. Today not required because it is a YouTube class or recording is there. You can watch it 100 times if you want. So, if I tell second time, same thing I have to tell. One advantage of online class, I don't have to tell again and again. Plus 14.19. Tell me, result by Kani's method perfectly same tallies with the SD method and MD method. Yes or no? Result by Kani's method perfectly tallies with the SD method and MD method. Yes or no? Fast. No error, nothing. Beautifully telling. Yes. Tell me, next step is go to where? Remember, those who are general public, it is not my problem. Tell me, those who are in the group, tell me. Next step is go to where? Tell me. Next step, go to. Sorry, others I don't anything. What is next step? See, question is analyze and draw SFDBMD. Analysis over. Next step, tell me those who are in the group. Next step is go to star. What is star? People who are in the batch. You know it or not? Tell me. Yes, star book you go there. In the star book, for these moments, already SFDBMD, over or not? Already your SFDBMD. Already SFDBMD, over or not? In the star book for this question, already over. Therefore, my today's YouTube class for general public is how to analyze by Kani's method and get the moment, not SFDBMD. SFDBMD already over. That first question over, second question will be continued. Okay. Now, over. This is the information only for the people who are in the group. Tomorrow, I will take the question of one side fixed, one side simple support by which method? Already SD method over. Tomorrow I will solve by which method? One side fixed, one side simple support. Tomorrow I will solve by which method? Tell me. SD method already over. Question number 2. Tomorrow I will take it by which method? First. This is only for the group people. Tomorrow I will take question left side MDM and also if possible I will finish by Kani's method. So I will write earlier FPM part all. Clear? So before the class I will prepare the writing. Why? To save time. Okay. Tell the corrections. Okay. Thank you. Go through the class repeatedly and learn Kani's method table. This table or this iteration process of finding contribution. In future, next time onwards, these values in your class, I will not explain. I will directly tell repeating value how much. Agreed? Next time onwards, I will tell repeating value how much. Clear? Repeating value, I know how to get by LT method. I got the tricks. When I solve by LT method, I will apply a trick and get the values by Kani's method. You never bother about trick. You solve the question and correctly understand. Okay, now, Kani's, fully clear? Full clear, Kani's method. With all explanation and concept. Okay, thank you. I will close the class. Tomorrow I will continue the class once again in Zoom only, not YouTube. Today's class you use in future when you get doubt, use the YouTube class. Okay, thank you.